0, recording. Okay, so there was no background, no pre-lab for the heat of fusion lab. So I am gonna slap something together here. I'll talk about it in a little bit of class, and if we'll be in class just a few minutes. Let's see. There is a playlist. And so it'll have this video eventually, but there is a really nice development in the whole lab. It's too bad that we can't actually have seen this before we go to lab. So yeah, we're gonna follow this. I have a detailed set of directions I made for you guys. I'm gonna print them. But let's go over it in a nutshell, and you can see this again. You know, like I said, we're gonna go over it in class. So we've seen the heat, and we've talked about when we changed the temperature of the water, and we had the metal in there, and we measured a specific heat. Now, in this case, we want to measure the heat of fusion of ice, and which is also the heat of melting, heat of freezing. And what happens is that the temperature doesn't change, so we have to figure out a way to do this. And so what will happen is that if we toss a hunk of ice into some water, it'll change the temperature of the water. And as long as it, well, it'll never be able to bring it down to 0. So when the ice melts, it absorbs energy to melt, and then that means that the water gets cooler. I said that already. I'm repeating myself. Sorry. And so the ice absorbs the heat gained, and then there's heat lost by the water. So if we have the mass of the water and the specific heat of the water, which we know about, and we know the temperature change, that gets us the Q of what the water lost, because the temperature is going to go down. And so that's going to equal to the heat gained by the ice, the mass of the ice, times the specific heat of the water, and the mass of the ice, and there's a little bit of the water. The ice melted. The mass of the melted water is the same as the mass of water. Okay. So a little bit of the ice is going to melt, and then it's going to be warmed up to T final. And it may sound a little strange but there's the water that's in the cup, and it loses heat. The ice gains some of the heat, but also, since the ice is melting, some of it goes from 0 to the final temperature of the water. And so that is the amount of calories to heat that bit of water. Okay, so I want to, of course we're going to melt, yeah, stupid. We're going to melt all of the ice, so then we don't need to know. Since we're going to melt all of it, we're all covered. Okay. This is good. This is practice for when I walk into class with you guys and try to explain this because I haven't gotten my act together to. Oh, that looks ugly. Okay. Why is it that this one looks different? I'll try doing this and see if it. There we go. Okay. So there's no sense going through the video and doing this, but we have an accepted value. We know the specific heat of water. We assume we know it, and that's nice. That makes our life easier. Okay, I think that maybe, well, this wasn't a waste of time. This way, I practiced my spiel in front of you guys. I'll post this anyway. And computer with the logger. I don't think we do that, have that, but we'll see. Okay. Anyways, I'm gonna post this up, and we'll see each other in an hour. Very good.